Does anyone else think of King Julian when they hear that all the time now? That's all I can get there. That's silly lemur. All right, anyway. Lesson 27. We got one-step equations, and this time, though, we are using our multiplication and our division. So remember from before, when we solve equations, the goal is to get just what x equals, or just what y equals, the variable all by itself. We want to figure out what the letter is. So to do that, it's all about undoing. So we do the opposites. So they're going to go visual here again. The whole idea is we've got 2x equals 6. So there's an x and there's an x. That's why we have two x's. And then 6 of them, we've got 1, a 2, a 3, a 4, a 5, and a 6 of those guys. We can't use addition and subtraction here because we don't have any of these green tiles on the other side. I don't know if you can see that they're green, but basically we don't have any square tiles on the other side. We don't have these rectangle tiles on the other side. So we just can't say like, hey, 2 of those squares is worth 1 of those rectangles. We don't know that. So the whole idea here is if we divide them both into groups of 2. So if we divide both sides by 2, all right, 2 divided by 2 gets us to our 1. So we take our 6 and we divide it by 2, we get 3. So in other words, each large rectangle that we called x can have groups of 3. So there's your visual for it. We want to get into the more formal approach there, which is actually doing the solving for them. So to solve a multiplication equation, we end up dividing. We use the word coefficient. Go mathematical here on you. Coefficient is simply the number the variable is multiplied by. In other words, who's the number that's right in front of the letter? So if we go to example A here, solve 3z equals 9, the number that's in front of the letter, yeah, that's a 3. So your coefficient is 3. Now, all you really want to remember is it's about doing the opposite. So what's going on between the 3 and the z? Well, they are multiplying. So to undo multiplication, we divide. Now, how we show our division, and this is something we've been working with for a while there. How do we show division? We use your good friend, the fraction bar. So we need to divide both sides by 3. And the whole idea here is 3 divided by 3 is 1. So we have our 1z all by itself. And we solve on the other side, 9 divided by 3, and that is 3. And again, I know what you're thinking. You're thinking, come on, 3 times what is 9? I know that's 3. We want to show you, so when the answers aren't as obvious, because we will get fractions, we will get decimals, we kind of know what's going on with them. I know I said fractions and decimals. It's okay. It's okay. We'll guide you through it there. All right, so let's come over here to our substitution to check our answer. Remember, the original equation was 3z equals 9. We're saying that z is 3. So when a number is up against a letter, it means to multiply. Is 3 times 3 equal to 9? It certainly is. All right, so let's move down here. Now we're solving a division equation. Now that's why we have our fraction bar, y divided by 4. We're going to use multiplication. Now this one's going to look a little bit more awkward with it. But it's just simply using our knowledge of fractions. So we've got y, and we are dividing it by 4, and it's set equal to 2. So the opposite of dividing by a 4 is to multiply by a 4. Now, what we're going to do is we just use parentheses off to the side to show what's going on, and we show it to both sides. So we get the answer of y equals 8. Now let's kind of look back here for a second as to why this is happening. Remember, what we've got here is... Okay, sorry. Had a little technical, so apologize for the glitch that happened there. So let's go back to right there. Why does it end up giving us just a letter here? Well, one is, remember, we are undoing. So when we undo, we get back to where we started from. So what's really going on here? Well, when you multiply by 4, 4 technically is a fraction. So because the 4 is a fraction, it's really going to be 4 over 1. So when we do that, 4 over 1, we should hopefully see some cross division that we've got going on here. So when we place it over the 1, we can see, there it is, well, 1, 1. So, because 4 goes into 4 one time, and now wait a second, 1 times anything, well, it doesn't change it. And then when you divide it by 1, it doesn't. So that's what's going on. We don't need to show that because, again, that's the benefit of solving the equation. We know that's going to happen. So let's come on over here. We have y divided by 4. Does it equal 2? We're saying y is 8. So do you agree that 8 divided by 4 equals 2? Yes, it does. So we do know that we have a solution to our particular equation that we are looking at. Let's go on to the next page. All right, so we're going to solve and we're going to check here. So we kind of brought out some of our decimals to play with here. But again, we're more interested in the setup of them there. We'll walk you through with all the division and multiplication and such. So we are solving, and then remember, we are checking our answer as well too. So when we look at that, you want to divide both sides by 3 5/10. Now, why are we dividing? Because what's going on between that number and the variable? Well, they are multiplying. So to undo it, we use division. So we're doing 21, and we're dividing it by 3 5/10. So when we set it up, the 3 5/10 is on the outside, the 21's on the inside. So we got to make it a whole number. So go once to the right. It's a whole number, so go once to the right. So we're really doing 35 into 210. Push that decimal up. Let's see here. 35 into 21, no, into 210. Let's see, 7 times, no, that's going to be, so let's go 6 here. All right, 6 times 5 is 30. Put down the 0, carry the 3. Oh my goodness. Really? Really? Did it really? 18 plus 3 is 21. There we go. M equals 6 for our answer. All right, so if we do our check step and we plug it in, it says if we do 3 5/10 and multiply it by 6, we should get the answer of 21. Let's see. 6 times 5 is 30. Put down the 0, carry the 3. 6 times 3 is 18. 18 plus 3 is 21. Now, wait a second. That's 210. Oh. One number to the right of the decimal, one number to the right of the decimal, so it is 21. You can also use your estimation there if you would like. 3 5/10 is close to 4. Leave the 6 alone. 6 times 4 is 24, so there's your decimal location. So yes, it does work, but remember, 21 is not my answer. 21 is just from my check. My official answer there is 6. Let's try the next one. We're starting on the side with the variable. Opposite of dividing by an 11 is to multiply by an 11. So we do show with the parentheses off to both sides. That is something we want to get comfortable doing here. All right. No, we kind of stay away from the dot just because it mixes with the decimals. I mean, you can use it, don't get me wrong, but you're going to see it mostly with your parentheses. So because we are doing the opposite, we know it's just going to give us the n. It's going to give us just the variable. What we need to do is the 2 7800ths and multiply it times the 11. It's nice because we're multiplying by 1. So 1 times 8, 8. 1 times 7, 7. 1 times 2, 2. Placeholder. 1 times 8, still 8. 1 times 7, still 7. 1 times 2, still 2. So when we add it all up, you get an 8. You get a 5. Carry the 1. A 9 and a 1 is a 10. Carry the 1, a 3. We're multiplying. I got 2 numbers to the right of the decimal, so I am going to go with 2 to the right there. So it is 30 5800ths. Again, if you had to estimate, you'd say that's close to 3. You'd say, well, let's just leave that as 11. 3 times 11, 33. Definitely close to it. To do your check step, we would see is 30 5800ths divided by 11. Does that give us 2 7800ths? So let's come on over here. Let's see it in action. Let's put your 11 because we are dividing by it. 30 5800ths. Push your decimal straight up. Now again, I should get 2 7800ths, so it should go in 2 times. Let's see if it works. 22. Yeah, that worked. Subtract, I get an 8. Bring down the 5. It should go in 7 times. So again, we're going to use it to help ourselves out. We just got to see if it actually matches up. 7 times 11. Yeah, 77. That works. If I did an 8, it would be too high. Subtract here. 15 minus 7 is 8. Bring down the 8. Oh, happy, happy, joy, joy. 11 times 8 is 88. So it did end up working out. So my official answer, where is it? Where is it? There it is. It is 30 5800ths. All right. Let's look at the next one. It's a little bit more pleasant, I would think. Yeah, here we go. 8p equals 44. So we start on the side with the variable. The opposite of multiplying by 8 is to divide by 8. So we're going to divide both sides by 8. So I got to figure out how many times 8 go into 44. So let's just do a little division problem there. All right. 8 goes into 45 times. Oh my goodness, I've got something left over. Add your decimal. push your decimal up, add your 0, bring it on down, and 8 into 45 times. Look at that, as fast as it was, 5 and 5/10. All right. Do your check step. Let's see, is 5 and 5/10 times 8. Does that give me 44? Well, that's a 40. We're going to carry the 4. 40 plus 4, that's 44. 1 to the right. Oh, there it is. It is 44, so it doesn't work out. So yes, 5 and 5/10 is our answer. Next ones that are down there is they want you to come up with an equation. So it is a multiplication equation, which means you need to use what operation in there? Yeah, you got to use multiplication. All right. And we want the solution to be 12. So I want the answer to be 12. So, geez, what could we? I need a multiplication equation. So I need a multiplication. I need a number up against a letter. So there's lots of answers here. I'm going to keep it easy. I'm going to throw a 2 down. So 2 times what, all right, is going to give me an answer of 12. Well, if we're saying x equals 12, plug it in. What is 2 times 12? Yeah, it's 24. Exactly. So if we do go through the process and we divide both sides by 2, yeah, we get 12. So I do have a multiplication equation. I am multiplying here, and the solution is 12. No. Look. Those guys are not the same. No, and they should not be the same. I want the solution to be 12. All right? So we want to make sure that we... Oh, my. Sorry, I got to turn the TV off there. All right. Last one. Write a division equation that's a solution of 12. Division equation. So I know I need a division problem there. All right. Your variable on top is always going to make it easier for you. You could put on the denominator. It gets into something totally different that we have not seen yet. So don't put yourself in that situation. And again, I need the solution to be 12. So I need the answer to be 12. All right. So, well, you can kind of choose what you want here. Again, keep it easy. If you want, check a 4 and see what happens. Now, again, the opposite of dividing by a 4 is to multiply by a 4. All right, and I need the answer to be a 12. So what could I multiply by? What could I multiply 4 by to get an answer of 12? Yeah, 3. All right. So let's see here. If we solve, opposite of dividing is to multiply. All right, because I did the opposites, all right, I get just my variable, and yes, x does equal 12. So there's my proof. There's my official answer, just like up before. There was my official answer, because it was the equation that we actually wanted. We did it! We did it! Yay! Oh, be proud of yourselves, people.